Okay, hi students. I'm going to do a video of the lab on page 9 through page 13 so that everybody that's been home can catch up on it. So really we're going to start on page 10. So open up to page 10 and we're going to start on this thing right here. This is going to do the different pages, okay? So we're going to start right here where it says divergent boundary. And in class, we took some Cool Whip and we put a bunch of Cool Whip in here and spread it all over the square. And we talked about how Harry Hess and Alfred Wegener discovered continental drift and discovered seafloor spreading. And we're going to model that, okay? So we took our two crackers and we take our two crackers and we stick them down. These represent the oceanic plates and the whipped cream represents the asthenosphere. And we're going to take these and we're going to push down and out. So we press down and out and make a divergent boundary. So you can see it's now separated out. This is what's happening on the bottom of the ocean floor at the mid-Atlantic ridge. And we see that the plates are diverging and going away from each other. And in the middle, we're getting one big ridge, one big mountain, okay? So that is what is happening at that zone. So on page 10, it says, what happened to the frosting between the crackers? What happened to the whipped cream? It made a mountain or made a ridge. Number 2, what do the crackers represent? They represent the oceanic plates. What does the frosting represent? It represents the mantle, okay, or the magma coming up. Name a specific location on Earth where this kind of boundary activity takes place. Well, it takes place at the mid-oceanic ridges and the mid-Atlantic ridge. It also takes place at at Iceland. Iceland is actually the mid-oceanic ridge coming up as an island in the middle of the ocean. So that's created by that mid-Atlantic ridge. It also is taking place under the Red Sea. The Red Sea is diverging and getting larger. Okay, number 5, what type of feature is produced by this movement? Okay, an ocean mountain range, under the ocean. Number 6, what is the process called that creates this new ocean floor from diverging plates? This is seafloor spreading, seafloor spreading. Another thing I want you to write down that there's no spot to, just find a spot on the page. But I want you to notice that this kind of boundary is constructive. It's building. And so you can see right here, it says at the top, it's a constructive boundary where there's a building of crust. New crust is being made, okay? There's nothing being destroyed, but new crust is being made. Okay, so now we're gonna move on to convergent boundary, continental to oceanic. So we're gonna do the same thing. I'm gonna get some whipped cream, spread it out all over the box here. Convergence means coming together. Divergent meant going away, and convergent means coming together. So we're going to have the different parts coming together. Now, we're gonna have a cracker again represent the ocean floor. We're also gonna have a Rice Krispie treat this time. And these are going to converge or come together, okay? And as they converge, we're going to see some things happen. Now, this is representative of the continent because it's lighter and less dense and fluffier and thicker. This is representative of the ocean floor because it's thin and dense and small, okay? And that's really like the continents. The continents are big and thick and fluffy, and the oceans are little and really dense, okay? Where this is less dense. So if we have a heavy, dense piece and a lighter piece, and they converge and come together, what's going to happen? Okay, the lighter continental piece is going to go on top because it's lighter. So we're going to converge these together, and you're going to see, let me show you here, you're going to see that the continent goes over the oceanic piece. The continent goes over the oceanic piece. The oceanic piece is going to go down and sink into the asthenosphere. When it does that, it melts. And so we have the oceanic plate melting under there, and we have it creating some heat and pressure down inside the asthenosphere. Because of that heat and pressure on the continent, we actually get volcanoes. That's how volcanoes are made, by that heat and pressure from these converging plates. So you get a volcano here. Now, what about this piece right here, right? If you look, you can see that inside the ocean, we have this way lower than this. This is actually creating an oceanic trench. And if you look on different maps, you'll see that the trenches are right there by these convergent zones. So let's answer the questions here on page 11. It says, number 1 on page 11, what happens when a tectonic plate gets subducted? What you're going to write down is that it sinks and it melts in the asthenosphere. Number 2, name a specific location on the Earth where this kind of boundary activity takes place. Okay, well, this takes place where North America and the Pacific plate converge. So the Pacific plate goes under North America, and that happens right there in Washington and Oregon. And that's why in those places we get volcanoes. So we have Mount St. Helens and Mount Rainier. They are volcanoes that are happening on the continent, and we see that convergence there. Number 3, what features are formed on the continent along this boundary? On the continent are volcanoes. And then it says what feature is formed in the ocean along the subduction zone. And right there, you want to write trenches. Trenches are formed in the ocean. Now, it's also important to know that oceanic to oceanic convergence does the same thing. When you have 2 oceanic plates, one oceanic plate goes underneath the other oceanic plate and subducts and gets melted in the asthenosphere. Okay, so these come together and do the exact same thing. So this would be a place like the North American plate going on top of the Pacific plate. A place where that happens is like in the Aleutian Islands in Alaska, where the Pacific plate is going underneath that North American plate, and you get subduction. And the Aleutian Islands are volcanic islands that are up by Alaska, and they are actually created by those volcanoes that happen because of the subduction. Another place where this happens is Japan. Japan is the Pacific plate going underneath the oceanic or Eurasian plate. As it does that, it melts the Pacific plate and creates volcanoes, which created the island of Japan. Also, the Philippines and Vanuatu and all those things down in the South Pacific, all those are created by the subduction of an oceanic plate. So that's the exact same thing, okay, that's happening here. Now, going to model for you on page 12, we're going to model the continental to continental convergence. Okay, continental to continental convergence. So we're going to make another layer of asthenosphere. And then for this one, we're just going to use 2 crackers, okay? And for these crackers, these represent the continents this time, okay? And what I'm going to do is I'm going to go over here and I'm going to get them wet. Okay, and I'm going to get my continental plates wet. And then I'm going to take these and I'm going to merge the wet ends together. I'm going to converge them together. And what we end up getting from this is we end up getting a mountain. I don't know if you can see my little mountain there. It's kind of hard to do on the video. But we get a mountain. Okay? So this is where 2 continents slam into each other, and they can form a mountain. So let's go ahead and do the discussion questions on page 12. Number 1 says, what happens to the wet ends of the crackers? And the wet ends rumple and smush up. Number 2, in what way do the wet crackers act more like actual crustal plates than the dry crackers? This is what happens. If you take 2 dry crackers and you put them together, it's just gonna break, right? It's not really gonna smush or bend or mush. Okay, they just break off. They're just breakable. But that's not really so much what happens with the crust, right? It doesn't just flake off or crumble. The crust, when they hit each other, they just mush and bend and mold together. And that's what's really happening with the crustal plates at a continental to continental convergence. Number 3, what feature do the resulting ends represent? This represents mountains. This represents mountains. And I'll tell you, this also answers the next question. Number 4, name a specific location where this occurs. This occurs at the Himalayan mountains. What happened is we have Eurasia up here, and India used to be way down here by Australia and Antarctica. Well, what happened was India began to move north, and it moved north and moved north over millions of years. When it hit Eurasia, it slammed into it. And the Indian plate is still slamming into Eurasia. And as it does so, we have a convergence of these two plates slamming into each other. And that is how we got the Himalayan mountains. Okay, the Himalayan mountains are actually growing by about 2 centimeters a year. And they are growing because they are pushing together right at now at this time with a continental to continental convergence. Okay, so write that on 4, Himalayan mountains. Okay, last one. All right, the last plate boundary is a transform boundary. So we're going to put down a little bit more asthenosphere here. Okay, and now we're going to have a transform boundary. This is also known as a strike-slip fault, and this is where two plates go past each other. Okay, they're going to rub up and past each other. Okay, up and down past each other. So we're going to show that here as they go past each other in opposite directions. Okay, and these plates, let me back up. So when we did the continental to continental, that was at the Himalayas. There is no volcanism there. Okay, no volcanoes happen at the Himalayas, but they do get tremendous earthquakes because of those two plates slamming together. So that would be no volcanoes. Same thing at the transform boundary. The transform boundary is two plates going past each other. There's no volcanoes, none of that activity, just earthquakes. So let's answer the questions on page 13. Number 1, why is this movement often described as horizontal sliding? Well, it's because the plates are horizontally sliding past each other, right? They're not going into each other, and they're not going under each other, and they're not going away from each other. They're just sliding past each other. Number 2, name a specific location on Earth where this boundary takes place. The most famous one is probably the San Andreas Fault. The San Andreas Fault is in Southern California, well, Northern California a little bit too. And that's right there on the edge of the North American Pacific Plate boundary. But those are trying to move past each other. That's probably really famous because lots of people live on that fault. And so when a earthquake happens there, usually people hear about it. So the San Andreas Fault. Number 3, nothing happens at the beginning, but when those plates are trying to go past each other, a lot of times they lock and they get stuck. And there's still pressure pushing them, trying to go past each other. And as they lock, that pressure increases and increases and increases till they slide right past each other. And those crackers finally break. What do we call the breaking and the vibrating of Earth's crust? Well, we call that an earthquake. That's all it is. It's an earthquake. All right. Okay, so that's all the modeling on this page. If you were here, I'd let you eat all this. Have a little bite of, Rice Krispie treat, but I'll just throw it away for you. But the conclusion, okay? Give an example of how plate movement directly affects the construction of Earth's surface. Okay, what I want you to do is talk about different constructive things that happen from plate movement. So you could talk about volcanoes are built, mountains are built, islands are built. Iceland was built by this tectonic activity. New crust forms, like especially at divergent plates. So we get all kinds of things being built, islands and volcanoes and all kinds of things being built, okay? Then number 2 says, give an example of how plate movement directly affects destruction of the Earth's surface, okay? And by that I mean not just like buildings when an earthquake happens, but I mean destruction of the actual crust. And we see the destruction of the actual crust at those convergent zones, at those subduction zones. So on number 2, right down to the subduction zone, we destroy crust. Okay, hopefully that helps you guys understand all the different things about plate tectonics. You need to know all of those boundaries and what they create and what they destroy and some examples of all of those. So hopefully that helps and catches you up from missing the plate tectonics lab. Thanks, guys.